Hey guys, welcome back to the new video of the ACID playlist. In this video, we would be discussing on isolation. In my very first video, I have explained how exactly the write happens into the database, and then we have deep dived into atomicity and multiple use cases of it. Then in my previous video, we have deep dived into the consistency. Now we would be discussing onto the third segment, which is isolation. Let's start. So what exactly isolation means? So managing parallel executions of our transactions on the same data. Assume there is this particular row having, let's say, account equal to 1 and balance equal to 100, and there is this transaction 1, transaction 2, transaction n, let's say multiple transactions are trying to execute at the same time on this particular row. So now managing execution of all these transactions in parallel so that like the performance should also be optimized, but at the same time ensuring primarily the data should not get corrupted. This is a database. Transaction 1 and transaction 2 both are trying to execute at the same time. Now in the database there is a table, there is a page, there is a row. Here we would be, let's say, talking about on the particular same row both the transactions are trying to execute it at the same time. Let's take an example. Our purpose is not to teach you the database. Our purpose is to teach you the internals of these things, how exactly it works. Account ID, account 123, balance 500, cool. Transaction T1, transaction T2. Transaction T1 fetching balance account ID, account 123, update balance 100. Similarly, at the same time, transaction T2 fetching account balance 123, update balance minus 50. On the same row, account ID, account 123, one transaction is trying to update it. So let's say it was 500. So here it is expecting 600, and here it is expecting 450. It has also fetched. It has got 500 and it has got 500. But the expected outcome is 600. It is expecting 600. It is expecting 450. Both the transactions are trying to execute or update the same row at the same time. Now, as part of an isolation, it has to ensure like which transaction is going to get executed, and finally how my data is going to look like. It can't happen. It should not happen like my data is getting corrupted. This can't happen because assume he's expecting like, hey, my transaction got updated and now my database value is 600, but at the same time someone is updating it to 450. After 1 hour back, he's coming and saying like, hey, last time when I executed the transaction, the balance was 600. How suddenly it got reduced to 450? It is the responsibility of a database engine to ensure like my data should not get corrupted. There can be multiple different issues when reading, when writing the data, because both the transactions or multiple transactions are trying to execute parallelly at the same time. There can be multiple different issues that can happen. Let's discuss on those issues which are read-write issues. Whenever you would be thinking of an isolation, you won't be able to understand isolation topic in depth unless and until you understand what is the fundamental issue that we are trying to solve. First is dirty read. Again, like for every single thing, I have a separate slide. We would be discussing that further. So first issue is a dirty read issue. Then the second issue is non-repeatable read. Third thing is phantom read. And then fourth the thing is loss update. So these three are related to the read issue. And this one is the write issue. So let's discuss every single issue in depth. So first is dirty read. Same example, account ID 123, balance 500, transaction T1, transaction T2. What exactly is the issue? Transaction T1 started fetching account balance 123. It received 500. It updated the balance. It is 600. Yet it is not into the database. It is just in memory. Updated the balance 600. Now before doing any further operation, transaction T2 started. It is fetching the account balance. Expected is it should 500. Why? Because this 600 is not yet updated into the database. It is just in memory of that particular transaction. Expected is 500, but actual value it is able to see 600. This is what I term it as a dirty read. You are reading a wrong data. You are reading such kind of a data which is not updated into the database. What is the problem? Assume it has read, it find like 600 and he's parting stating like, hey, my account balance is 600, but before it updates it into the database, due to some reason it wants to roll back. It roll backs the transaction. So now your database originally was having 500, still it is having 500 because this was never updated into the database, but this transaction is in an assumption like, hey, my account balance is 600. This is what a dirty read is. Let's move on to the next one, non-repeatable read. Same. Account ID 123, balance 500, transaction T1, fetch account balance 500. Cool. Update account balance 100, 600. Before it performs any commit operation, transaction T2 it is reading and it is seeing expected 500, actual 500. You would be saying, hey, yes, good. This time there is no dirty read. I was expecting 500, I am actually getting 500. Why? Because this was not updated into the database. Great, cheers. Now it performs the commit operation. After it performs the commit operation, this got updated into the database. Assume updated in DB to 600. Now I am fetching the account balance once again. This transaction is in process. Okay, this transaction has not yet terminated. This transaction, assume this transaction got terminated and the database is having now 600 value. This transaction is in process. Again, because of some reason it is firing a fetch account balance after the commit instruction and it is now seeing 600 and expected is 500. So you might be saying like, hey, once now my database entry is updated, my database is having 500, the data is freezed. Why should I see 500? Why shouldn't I see the 600 is the updated value? The problem is because this transaction is in process. It is in process. It has not yet completed. Initially, before performing, let's say some set of instructions, it is happening. Set of instructions it is executing, and before doing that it has fetched and it is seeing like, hey, 500 is there, let's say, and he is performing some operation here, and now suddenly he sees like, hey, my account balance is 600. So now all these instructions, they were performed on this older data 500 and suddenly the new data is changing. So within a transaction, now I can't trust it because I do not know when my database value is going to get updated, and all the values that I am updating or all the instructions that I am performing, I am now performing it on the shell data. So now what should I do? For me, if I have started a transaction, I have fetched, I saw this particular value, this value should stay consistent across my transaction is completed. This value can't change. If this value is getting changed, then this is a very big problem because now my set of instructions, all the operations that I have performed till now, all the operations are in vain. All the operations are like wasted because I have performed now the operation on the stale data and now my database is having a new value. That is the big problem. This is what non-repeatable read means. Now let's discuss on to the next part, which is phantom read. So now in this phantom read, let's take a different example. So assume my table is there, user table is there, and in my user table there are 3 users, user 1, 2, 3. User 1 is having an age 30, user 2 is having age 25 and user 3 is having age 35. Okay. Now transaction 1 starts. Fetch user age between 20 and 30. So it is trying to fetch all the users having the age between 20 and 30, and now 20 and 30. So 25, 30, this. So now it will be getting 2 users, that is user 1 and user 2. Cool. It is fetching the user between age 20 and 30. Total user is 2. It is also getting 2. It is also getting 2. Cool. Now it is inserting new user. User 4, which is of 24. So now in my database, I am having U1, U2, U4, which is between 20 and 30. And only U3 is having 35. And it is committing. So now my database is having 4 rows. Now it is fetching. When it is fetching, it is again still able to see user, total user 2 only. It is not able to see the third user, that is user 4, and that is the problem. And this is called a phantom read. Phantom read means if I am inserting or if I am deleting, I am not updating the data. Okay, I am inserting on deleting, and that is going to increase the number of values, but still I am not able to see that. Phantom read means if insertion or deletion something happens, and in the same transaction, if I want to execute that, those new values I should be able to see, the new added rows or new deleted rows, but I am not able to see that. That is what the issue of the phantom read is. Now let's finally discuss on the last part, that is lost updates. So lost updates, same example, old example, account ID 123, balance is 500, begin transaction, fetch account balance, here it is able to see 500, here again at the same time raise condition, both are executing 500, it is updating it, it is now able to see in memory 600, here it is able to see 450, this is also committing, this is also committing. What is the expected output? Expected is 550 rupees. How 550? Assume 500 plus 600 minus 50. So it is 550. He should be able to see 550 because even though the transactions are getting executed at the same time, at an isolation level, at a database level, it manages it sequentially. It ensures that it executes in sequence and both the instructions are taken care of and the proper value is updated into the database. This is what the expected is. But the actual value is 600 or 450. So either this is getting executed or this is getting executed. So now the problem is, this is let's say user 2 and this is let's say user 1. So he is thinking like, hey, I am having 600. He is thinking, hey, I am having 450. But now let's say my database is having 600. It is his expectation. And when he is firing a select query, he is getting actual value as 600. So now this is wrong. He was expecting 450, but he is getting 600. Now this is wrong. Why? Because he was given like, hey, your commit is success. When he is saying commit is success, he should be able to say 450, but he is instead seeing 600. This is what the actual problem is. So his update was lost because it took the precedence. Now how the precedence takes, everything we would be discussing later in depth. But this is what the lost update means. Like, okay, either his update is lost or his update is lost. This is what the problem of lost update is. So this was a read write issue. that is actually happening into the database when multiple transactions are trying to execute at the same time on the same row, and this is what with the help of isolations we would be solving now. At an isolation, there are these multiple different levels. That is very much important. How are we solving that problems? We are solving that problems with different levels. So there are 4 primary levels: read uncommitted, read committed, repeatable read, and serializable. Let's deep dive into every single level. So read uncommitted. This is a default in MySQL, not in Postgres database. These isolation levels are configurable. You can set the isolation level what you want based on your business requirement, based on your application requirement. But if you are using, let's say, MySQL database, so this is, let's say, by default read uncommitted. Now because of this read uncommitted, the issue that is going to happen is dirty read. And again, one thing that you need to understand is, from top to bottom we have discussed. So if dirty read is there, means all other below issues are present. If non-repeatable read is there, means dirty read is not there, but then phantom read, loss update, all these issues are there. So by default for MySQL it is read uncommitted, not for Postgres. And if this is an isolation level that is set, so then there is a high chance for dirty read. But what is the pros and cons? So this is the con. But now what is the pro? The pro part of this is basically it would be much faster. Again, whether this is correct, whether this is wrong, everything is correct, everything is wrong. It depends on your application to application. You can't say like, hey, read uncommitted is absolutely wrong, no one should support that. No, it is not correct. Based on an application, based on my use cases, let's say there is a chat application or my video streaming application or stuff like that, where I'm okay for losing my data, seeing the old data, seeing the corrupted data, whatever it is. If that is the demand of my application and my application demands it should be faster, read uncommitted is perfectly suitable for me. So as a designer, it is your responsibility to understand what is the ask of your application, and based on that only you set your isolation level. So by default read uncommitted, it supports dirty read, means it have non-repeatable read, phantom list, loss update, everything is there. The next thing is read committed. Read committed is the second isolation level. This is updation part of it. So read uncommitted, this is a default in Postgres. If you are setting your isolation level as read committed, again you can set it, you can configure it in MySQL, no harm in that. So if you are setting a read committed, dirty read won't be there, but there is a high probability that you would be having a non-repeatable read. So this is a con. Pro, faster, but less than read uncommitted. So you are safe from dirty read, but still you would having an issue of non-repeatable read. Then comes the repeatable read. With this repeatable read, you won't be having dirty read, you won't be having non-repeatable read, but still you would be having a phantom read. So if your application demands, right, hey, I'm okay with the phantom reads, I do not want that updated or inserted new rows, but I'm not okay with getting in the same transaction the updated value, but I'm okay of not getting the new added rows as well, then for you the repeatable read is suitable. Finally, and the most efficient one is the serializable. With serializable you would not be finding any issues, but here you won't be having anything, neither phantom read, neither loss update, nothing. This is at an extreme isolation level. You can set it both for MySQL and Postgres if your application demands. With this there won't be any issue at all. The biggest con of this particular thing is your database query would be much more slower. So if your application demands and if you want to still go with the SQL database and you want the 100% database protection, then you can go with the serializable, but then you have to consider your performance would be extremely slow. So this is what about isolation levels are. Now finally we would be discussing on how isolation is achieved. So there are two mechanisms primarily. Again it depends from database to database. Either you can go with locking or you can go with MVCC. First we would be discussing on locking. This is what MySQL uses. So at a locking, there are two major types of lock. Again, there are multiple different types of lock, but majorly there are two: shared lock and exclusive lock. Most of the people, around 99% of the people, won't be knowing that like whenever you are fetching the data, the row is not locked. It is wrong. The row is locked. Whenever you are firing a select query, it is always inside a transaction. First thing. Second, always there is a lock hold. Which is the lock? Shared lock. Shared lock is always held whenever you are reading a data. When you want to perform an insert, update, delete, a mutation statement, a DML statement if you want to perform, at that time this is an exclusive lock that is taken. So there are two types of lock: shared lock, exclusive lock. Shared lock is taken when you are reading the data, select statement. Exclusive lock, it is taken when you are inserting, updating or deleting the data. The very most important thing, concept that you need to understand is, you can't acquire any of the lock randomly. First lock has to be released, then only you would be able to acquire second lock. So for an example, there is a transaction 1 and it has acquired a shared lock on, let's say, row 1. Transaction T2 comes and he's saying like, hey, I want to update, so give me a exclusive lock on row 1. It has to wait till T1 releases shared lock. So there is no precedence like exclusive lock is having higher precedence as compared to shared lock. No. Again, it is vice versa. It is opposite. Like if an exclusive lock is held, shared lock can't be acquired. It has to wait unless and until one lock is released. The second lock can't be acquired. Why this is important? Because we want to achieve isolation. So we have observed like, okay, there are multiple different issues and multiple different levels are there. Now how those level works internally, like how we are protecting the data, how we are ensuring like there is no dirty read, non-repeatable read, lost updates or phantom reads, how we are ensuring, how database is ensuring. This is how it is ensuring. MySQL at a MySQL level, it is playing with the locks, shared lock and exclusive lock, and this is how the lock mechanism happens. So these were the types. There are multiple different levels. You can acquire a lock at a row level. That is a very niche thing. The bigger part, you can acquire a lock at a table level. Then you can acquire a lock at a page level. And then finally, you can acquire a lock at a whole database level. As and when you increases these levels, there are two things. So the very most important thing that you need to understand is what the level decides. The level decides granularity and increased performance. The more the granular level you are taking a lock, the more your performance is. Assume I am having row 1 and row 2 and I am taking row level lock. So T1 is took lock on R1, T2 comes and he wants to update R2. So because I have taken a row level lock, there is no lock on row 2, so T2 can take a lock and he can perform at the same time. So now my performance is increased, granularity level. But what is the con? The major con of it is managing locks and leads to deadlock situation. It is not a silver bullet like we are saying like, hey, row level lock we should acquire to increase the performance. Just don't think always from a performance perspective. You have to think from deadlock or different issues that can occur because of this granularity. If your system requires extreme performance, great, go ahead with the granularity. But at the same time, then your code should be in such a position, your design, your LLD should be in such a case like it should try to avoid these kind of issues like deadlock or different kind of an issue. It should try to handle it at an application level. Databases would do always its best, but at an application level also you have to ensure like these issues are avoided. If there is a pro, there is a con. Here there is an increased performance, but then managing lock, this again requires more memory. Plus there is an issue of a deadlock. That is the issue. So at a row level, we are acquiring a lock at a row level table. We know we lock complete the table. So let's say if a transaction wants to perform an operation only on row 1, and let's say that table is having let's say 100 rows, so 99 rows. If any other transaction want to perform operation on these 99 rows, no one would be able to do because the table is completely locked. The better than this is basically this is something which is there, and then the better part is page. Page level lock. What does page mean? So at a database level, everything is saved in the blocks in the format of a page. So one page can have multiple rows, multiple information one page can have. Assume there is a table and table is having let's say 1,000,000 rows. So now all those 1,000,000 rows can't be accommodated in that particular page, right? So 1,000,000 rows, let's say it is getting spread across 100 page for an example. If I want to perform an operation on a row 1 on that particular table, if I am taking table level lock, then I am locking the complete table, means I am locking a complete 1,000,000 rows. But if I am taking a page level lock, so assume there are 100 pages are 100, which is having let's say 1,000,000 rows. But because I want to take a lock for row 1, I would lock only let's say page 1, and in this page 1, let's say there are only 10,000. So now I am just locking 10,000 rows. If I would have taken a lock at the table level, I was locking 1,000,000 rows, but here I am locking just 10,000 rows. Again, this is best or not, it depends from your application to application, but this is the benefit of having page. One thing you need to understand, page is not a substitute to the table. Table is something which user is viewing, but at a database level, everything is getting saved at the page. And if you are taking a page level lock, then in that particular case, you are just minimizing the number of rows that are getting locked. You are not locking the entire table, you are just locking that particular page, that particular number of rows. Then the final thing is at a database level. This is at an extreme where you are completely locking your complete database and every tables, everything is locked. This is done only, this kind of a lock is taken only at an extreme case when you want to do a complete database migration. In 90% of the cases, the database level lock is not taken. The second thing is MVCC. This is being used in Postgres. Postgres doesn't use this locking mechanism. It doesn't mean like it doesn't have an exclusive lock for writing. It has an exclusive lock for writing, but there is no shared lock. MVCC means multi-version concurrency control, means both the transactions are allowed to perform the operation at the same time. Consider this thing in MySQL, when both the transactions are trying to perform, one lock has to be waiting till the another lock is released. Here, even if it is acquiring a lock, both the transactions are performing at the same time. How does it work? It works based on the version. So if my data is having, say there is my row 1 is having 500 rupees. So let's say there is this version V1. Now T1 wants to update row 1 from 500 plus 100 equal to 600. And T2 wants to again like R1, 500 minus 50 is equal to 550. So now when both the transactions are happening, this is going to update and it is going to have, let's say, version V2 and it is going to have, let's say, version V3. So whenever it is going to update the data in the database, it is going to see the versioning. It is going to see, okay, which is the state, which is the updated version, and based on that it is going to update the database entry. Because of this, now the old data is still present, the old version is still present, but now my database is having a new row inserted with the new version. The old row is still there, the old row is not overwritten, but the new row is inserted into my database with the new latest version. Again, like this is not going to be having V3, sorry. So transaction T1 R1 500 600 500 plus 100, that is 600, version V2 same it is happening, 500 minus 50, that is 550, and again it is having version V2. So now both are trying to insert it into the database. Only one version data is going to be getting updated, the another version is going to get automatically discarded, and the old version still be there. So in my row there would be, like in my database, there would be version 1, there would be version 2, this is my new version, this is my old version. After some time the compaction happens and this data is getting automatically deleted, and my database is only going to have version V2. This is my stale data. So whenever someone is going to fire a select query, they would be only getting version V2. So if, let's say, if this is getting inserted into my database, then this would be getting discarded, and when this would be getting discarded, it would be getting failure to user. So I am not saying like I am saying 550 is commit to the user. No, I am discarding this. I am just allowing this thing. Now the benefit is the faster read, the faster write. Multiple fast operations are happening because both are allowing. No one is waiting for the lock to happen. Less chances of a deadlock situation. But the problem with this is my database is going to require more space, because now I am going to have multiple different older data. So firstly, more space is required, and the second problem is in between, like in Java or some places, it happens like the garbage collection happens. Similarly, I need to execute the process which is going to remove the stale data, which is going to remove the old data. Plus the third issue is I need to manage multiple different versioning. The best part is the performance is enhanced, but the worst part is these are use cases that I have mentioned. So this is what about isolation that I wanted to discuss. So if you feel something valuable, knowledgeable I have added in this particular video, please do consider liking this video, subscribing to my channel for such engineering content. If you feel something wrong I have said, or if you want to appreciate or have any such questions, please do comment it into comment box and I would surely reply to you. In the next video we would be discussing on durability. Thanks for your time.